introduction of finding area between two curves. That is basically when on a graph there are two functions. Finding the area between the two curves is basically if there's a linear function and a quadratic function, the area between those two curves is this part. And so this is an introduction of finding that area. For our first question, determine the area of the region bounded by y equals 8 over x, y equals 2 times x, and x equals 4. So our first step in solving these type of questions where it asks you for the area is to set up a graph. And the way you set the graph up is to either input these equations into a graphing calculator or plug in x values to get certain y values and do that to graph each function. So to make it easy, we'll start with the last equation, x equals 4, which is easy because it is just a vertical line. This is x equals 4. And what we can do now is I'm going to graph this on a graphing calculator, and what we get is this equation is y equals 2x. It's a linear function, and this is y equals 8 over x. So now that we have graphed these three functions, we can see easily in this question that the area bounded by these functions is the area in the middle, which is this area. And to find that area, we can use our knowledge of integrals to integrate a certain definite integral function. So our first step was creating a graph, and our second step was identifying what area we're solving for, and our third step is defining the bounds of our integral. Our lower bound will be what x value the functions start at. So what x value does this area start with? And that is, as you can see, x equals 2. If you want to find out what this point of intersection is without graphing it or finding where it intersects, you can always set these equations equal to each other. 8 over x equals 2x, 2x squared equals 8, x equals plus or minus 2. In this case, it will be positive 2. So now we know x equals 2 is our lower bound. That's where the area begins, and this is where the area stops. That's at x equals 4. Now we're only going to be working with the functions that define y. X equals 4 is more to just tell us what the upper bound is, or where the area gets cut off. So those are our bounds, and now to create our function, we need to subtract the top function by the bottom function. So in this case, the top function is 2x, and that is subtracted by the bottom function, which is 8x in this case. And the reasoning behind that is, for example, if you're taking the linear function y equals 2x, we can integrate from 2 to 4 of this linear function, and it would give us this this trapezoid, this region. And so if we were integrating 8 over x, that would be this region. And so if we subtract this 2x integral from 2 to 4, and if we subtract that area minus the area of 8 over x from 2 to 4, then we get this area in the middle. So that is what our integral reflects, And now all we need to do is solve this integral. You can use the power rule, 2x squared over 2. The 2's cancel out, minus, and this is an identity, 8 times 8 over x is same as 8 times 1 over x, and 1 over x, the integral of 1 over x is natural log of x. That is an identity. And we're integrating this from 2 to 4. So now all we need to do is plug in our values, and we should get, after plugging this in, we should get 12 minus 8 natural log of 4 plus 8 natural log of 2, and that will give us, we can add these and subtract these. We can simplify this equation to get 6.4548, and we can use a calculator for this part. The hardest step is creating our integral and via making the graph. This is our next question. Determine the area of the region bounded by y equals x squared plus 2, y equals sine of x, and x equals negative 1, and x equals 2. So whenever you find x equals, or a function in terms of y, or constant, or it's defining x, if it defines x, it's most likely a bound, a lower bound or an upper bound. So as always, our first step is creating our graph. In this case, we see that since two x values are defined, we can assume that that is our bounds. So we can, this is our one vertical line, x equals negative 1, x equals negative 1, and x equals 2 is our next vertical line. So these are our two vertical lines, and these can be the bounds. This is where the area will not exceed. Now we can graph x squared plus 2 and y equals sine of x, and we can do that using a calculator, and we get something that looks like this. So this function on top is y equals x squared plus 2. That's this function on top. And the function on the bottom here is y equals sine of x. Now for these advanced type of functions, we should probably use a graphing calculator or a website to graph these equations for us. And now we can set up our integrals. As I said before, our bounds are negative 1, lower bound, and upper bound is 2. That's because the area does not go below negative 1 and does not exceed 2 in terms of x. So our function is the upper function subtracted by the bottom function, right? So we'll get x squared plus 1 minus sine of x. And now all we need to do is integrate this. And once we integrate this, we should get something along the terms of 1 over 3, 1 over x cubed over 3. Using the power rule on each of these terms, you get x cubed over 3 plus x I accidentally wrote x squared plus 1. it's x squared plus 2. This is x squared plus 2 because the function given to us is x squared plus 2. So x squared plus 2 minus sine of x. So x cubed over 3 plus 2x using the power rule on each of them. And then negative sine x turns into positive cosine x using the power rule. And we're integrating this from negative 1 to 2. And then plugging in these values, 2 for each of these terms, subtracted by 1 for each of these terms, we get something along the lines of 9 plus cosine of 2 minus cosine of 1. And that is equal to, using a calculator, we get 8.04355. So that is our answer for the area of the region bounded by these equations. And these x equals negative 1 and x equals 2 is our bounds. It just, if we didn't have x equals 1 or x equals 2, then this area would be infinite. It would keep going on either sides. So x equals negative 1 and x equals 2 is more of a bound. It helps us to identify exactly what area we're calculating for. Next question, find the area of the region bounded by the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. Now looking at this, we know that f of x equals y and g of x is equal to y as well. So one thing I notice is we don't have any x values, so we don't know what are the lower and upper bounds. We don't know any of that. So to find that, all we need to do is find the points of intersection. Now, before that, it's better to draw a graph, but in order to find out how to draw that graph accurately, we need to find out our points of intersection. Now, our points of intersection can be found simply by setting them equal to each other. Because if we set them equal to each other, we'll find any points of intersection. And the reason I say find points of intersection is if for example, if this is the graph of one of them and this is the graph of another function, then where they intersect is where the endpoints are, or where the bounds are. That's where the bounds are. So the area needs to be enclosed in this region, and so our definite integral will be from this to this. So that's why it's important to find the points of intersection. Now, after solving this, we get that 3x cubed, we can add x squared and subtract 2x from both sides, and we get this equals 0. Now we can take an x outside, so we get 3x squared minus 12 equals 0. We can also take a 3 outside, so we get 3x x squared minus 4. And so we see that our points of intersection are x equals, using the zero product rule, we find that the points of intersection are x equals 0, x equals 2, and x equals negative 2. These are our points of intersection. And so now we can graph these functions in and put the bounds as negative 2, 2, 2. 0 will be in the middle. And now graphing it using graphing calculator, we get something along the lines of this. something along the lines of this. So it intersects at -2. This is x equals -2. X equals 0, it also intersects. And x equals 2, it also intersects. So this function, the function with the arrows on it at the endpoints, is y equals -x squared plus 2x, and the function, which is a bit curvy without arrows at the end, is y equals 3x cubed minus x squared minus 10x. So now that we've identified what is each function and we've graphed it out, we can identify separate areas. So since we have 3 points of intersections, we need to first figure out the area of this, and then find the area of this separately, because there are 3 points of intersection. And so we can add this area and this area. So working with this area first, we can see that the function on top is this, y equals 3x cubed minus x squared minus 10x. So we can integrate that with the point of intersection being at -2 and the next point of intersection being at 0. We can find this area by subtracting the upper function by the lower function. So we get 3x cubed minus x squared minus 10x subtracted by, and now I'm going to erase to make space, subtracted by our lower function, which is -x squared plus 2x dx. And then we can add this to this area. So far we have this area, and we have this area, and now we're going to add it to this area. So this area, the upper function, is no longer 3x cubed minus x squared minus 10x. It is now the -x squared plus 2x. Also the bounds have changed. So before it was -2 to 0. For this area, it's 0 to the next point of intersection, which is 2. So 0 to 2 is our next bounds. And our function is going to be the top function, which is -x squared plus 2x, subtracted by our bottom function, which is 3x cubed minus x squared minus 10x. So this is our main, where the hardest part of this question. And the next part is to solve these definite integrals.